Hello everyone, welcome back to the lab. Well, today there is another project on the bench. As you can see, it's an oscilloscope. Is an HP 1745A. Is 100 megahertz oscilloscope. I believe it has been produced around the end the 70s or 80s, middle 80s. So, not sure, but this is what is my belief. Perhaps when I will open, I will see something that give me a better idea. The unit is a bit dirty. There is missing scutcheon here, and is a broken push button. But all in all, it's quite good condition. It has a nice and wide screen if you compare to the 1740 types, and so the unit should be functional, but not at the level that it is expected. And moreover, if the information that I have are correct, the lines are very thick. They are not so fine, so perhaps there are some ripple problem or some high voltage problem, focus, or any other kind of analog driving signals to the CRT. However, I'm not quite sure which is the time that has been switched on last time. So I will open the side cover, both up and down, and I will start with my variac, since I'm not quite sure that is a short time that has been power on, and hopefully we will see something alive. So let me do the setup and see what's happened. This is the inside of the instrument after the removal of the side panels. Well, actually covers. The covers are really dirty, and they feel like gummy, so I'm not quite sure if there are some contamination due to liquid or something like that. So hopefully nothing has dropped in the instrument. It seems to me that somebody has been already in. Let me zoom in a bit. So this don't see. Yeah, I don't like to. Seems that not original, and also this bridge need to be checked more in depth. Okay, but all in all, it's very clean. And let me tilt on the other side and see how it's in. Yeah, it's a very clean instrument. Very clean. Okay, power cord is connected. Switch the instrument on and start to rise up the voltage. So we are now at around 50 volts, 100 volts. Okay, so we just barely see the LED lights up. So no magic smoke for the moment. Looks good so far. So not quite sure if this should be like that. Okay, so let's try to increase the intensity, so maybe the filament is not already heated up. Bit more, 120, 140 volts. Okay, 160. Reset. So auto. Okay, we have flickering, so it seems that the horizontal section maybe it's working. And so let me move the, okay, I'm seeing something on the screen. So there are life signs. Let me reduce this. Oh, very thick. Okay, this is the scale that I'm very thick, and also it seems that okay. Oh, very thick. It looks to me like astigmatism. That is not correct, or perhaps the high voltage. So let's rise up volts and see what's happened. Okay, let me reduce sensibility. Okay, this is not normal actually. This is something that should not happen. Channel 1. So, oh, very strange. Okay. So let's go ahead with the increase of the volts. Okay. Now stabilize a bit and it looks more as it should. Still very thick, this line. Let me try with focus. Very thick. It's almost let's say 1.5 millimeters. Very thick. So I will let the instrument sit to this voltage for several minutes and I'll back. Okay, it's almost 10 minutes that the instrument is running at 215 volts, and the line still is very thick. So I opened the page of the service manual to the adjustment procedures, and this is what it is stated on. Look at that. Voltage and the relevant ripple over there. Now, I've checked already the first three and they already are out. But I have put the probe on TP5 where we should have less than 5 millivolts. So, look at that. Sorry for this wide movement. I have something like 5 volts. So this is very high. I think that it's better to switch the instrument off and check what can cause this very high ripple. A capacitor or perhaps some diode. So let me check more in depth. So this is the schematic, and here we have the relevant bridge. The TP5 is over there. It's relevant to plus 43 volts, which is right here. So we have two capacitors, electrolytic capacitors, C6 10 microfarad. This is the output going to the other circuit, and here there is the input filter. So the main filter is C5, which is exactly on the board this one. So I think, well, if you look at the capacitors, they don't look very healthy. I think that this unit should require a full recapping, but I would like to see if I can get some improvement just replacing this one. Moreover, I was hearing a very humming transformer
but after a while the humming went down, so I believe that there was a huge power consumption from some capacitors. Temperature remain low, but they are quite big, and the time that has been powered on maybe is not it has not been enough to make them warm. So I will cut this strip and remove these capacitors, those capacitors both. I would like to check them and see if replacing it makes some change. Well, this is what I have done. I have removed one terminal from the board of each capacitor, and actually none of them are very badly leaking, nor leaking neither open. So this is strange to me. What I've seen actually, it is that here it's missing one screw. So I wonder if this screw maybe pulled to the ground something. Here on this side I cannot see nothing. So I decided to remove the board and see if there is something that can give this problem. And moreover, I will check also the other small capacitor, that small capacitor is over there. But that sounds very strange to me. Okay, let's see what's happened. This is the board removed from the scope, and well, it's not a very simple task. However, as I said, none of those capacitors looks very bad, and the broken screws that is in this hole actually does not connect any ground, since this is the pad. So, but look at that. It seems that here we have a very bad signs of overheating, and somebody has tried to clean it up. And I have seen that also there is this tiny trace that also looks a bit overheated. So perhaps there was a short circuit in some other board. Well, actually, as you can see, this is an interface board that it is connected here. And okay, so actually there are indicated the lines. So it seems it was main gate. So perhaps there was a short circuit on this line. Don't know. Well, so going ahead, I will check all the bridge here. As you can see, one of that has been replaced, and perhaps also some other, not sure. However, to have such a high ripple, I believe that there is some fault on this bridge rectifiers or some other capacitors in some other places. Perhaps this is not the right one. I'm not quite sure in which line it is connected. So, some investigation to be done. Well, I think I found something wrong here. Let me see if I can put everything in the camera. So, this bridge, negative lead is on the alternate side, and positive lead, the red one, on plus of the bridge rectifier. As you can see, nothing on none of the two sides. So I can reverse and move, trying to make a better connection. No one. And on the other side, so on the negative side, okay, so it seems that one diode of this side of the bridge is dead. And if I go on the other side, so I'm with negative still on the alternate, nothing. And here we have a diode. So it seems that we have two broken diodes, and this can be the cause of very high ripple. Well, actually this output is relating on this line, so the one that I saw a very high ripple, it was another one, but I see another bridge with one diode dead, completely dead. I can't remember if this, no, okay, on this side another completely open diode. So there are two bridge rectifiers that are faulty, so must be replaced. Let's see if I have in my hand that, and if they are original. And indeed, what I've seen on circuit, I'm seeing also outside. So it's connected to both AC input and to negative side of the bridge rectifier. So here it gives me two diodes. That's correct. So if I move on the positive side, it's giving me only one diode. So for sure here we have a missing diode, and this can cause, of course, an high ripple. So I will remove also the other bridge and check it, and unfortunately I don't have any in my hand like that, so I have to order it and wait for the new parts. Well, the second one is even worse. Look at that. Positive side, one diode. Let's move on negative. One diode. So two missing diodes on this bridge. Well, at this stage I wonder why, if it has been a short circuit that has been repaired in the past, since I was seeing this burned trace, or if the problem are the capacitors. Well, this is very strange. Two bridge rectifiers faulty in the same board, it's a rare condition. So I wonder if for troubleshoot somebody has made some short circuit or some unexpected contact on the board and damaged the bridge rectifiers, because the capacitors are not really bad. So let me measure this, that it was the one with 5 volts of ripple, and this should be 500 microfarad, and indeed is 522 with 0.7 loss and ESR of 0.18 ohms. Not too bad. And the other one are not so far. The higher loss that I found was around 2%. Well, that's not brand new, of course, but nothing that make the instrument overload the bridge rectifier and damage them. Capacitance is exactly in the range. So let me check also the other capacitors and see if the type of bridge installed is the original one. And indeed the one of the bridge that were removed from the bird is not original, since in the drawing of the bird we have this rectangular shaped bridge rectifier, so for sure here was installed another type. So let's see if we can find the right replacement. Here is a real mess. So the one of the bridge that has broken is 401 amp and is the original. Look at that. This is A16 bird, but the other one, which is CR4, A16 CR4, should be 100 volt 5 amps, and it has been replaced with W04M, which is rated at 1.5 amps. Look at that. 1.5 amp 400 volts. So this is the right replacement for the other one, but not for this. So perhaps the spikes generated by this bridge, because it was not capable to rate 5 amps as required, generate a lot of damage around here. So, well, need the right bridge. Let's see if I can find something. So I'm stuck at here because of the lack of the replacement for that dial bridge. I decided to give a good cleaning to the front panel, and I start to remove all the knobs, which are over there, and I discovered that one of that is completely broken, and indeed is the one that is the delayed control knob, and in fact is the one that is missing the front cover. This is the one that is missing the front cover here, and the knob is broken in several pieces. So I will try to glue with super glue and see the final result. And so the knobs are quite dirty, and yeah, so I hope that I will be able to clean it. It's quite difficult for me to remove those push buttons, which I've been able only to remove 2. They are very tight on the lever, and I'm afraid to broken, but they are really dirty, as it is the front panel. Look at that. So I will try to remove and see if I will have the chance to clean very in depth. So let's go ahead with the cleaning. As you can see, I finally had to remove the vertical input board, and what I found it was this push button, that the latching mechanism was faulty. Somebody has completely bent this small leaf. This is a copper spring leaf, this one, and it was completely up, and in fact if I lift up this, it does not latch anymore. If I just leave it, it will latch again. So I have removed this C-clip, the spring, and this is a U shape, so I bent back again. Unfortunately I didn't catch the video for that, sorry. Moreover, I have seen that there are some oil signs. Perhaps somebody has tried to lubricate the push buttons to make the latching mechanism work again, but of course it was not possible like that. So I will clean everything, all the push buttons except those remain that I still need to remove from there are in the cleaning bath. So let's go ahead with the cleaning. All the buttons and knobs are cleaned now, and this is the way that I have cured the broken knob. It was broken in 4 pieces actually, and I found also another push button broken that I have glued with super glue, and I will polish later when it will be completely dry. I also have washed some of the push button connections rod, and well, so it's time to clean the front panel and see how it looks like. And this is the front panel without any knob and push button, and it's clearly very dirty. So there are also some sticker signs. Let's see if we can improve the aesthetic of this front panel. This is the result after a bit of cleaning, so I can't go over than that. It's very easy to damage the this light gray, so I can't go over, and the removal of the sticker residues is almost impossible since it's very hard. So I will try later when I will flip upside down the instrument to make some more pressure with alcohol, but well, for the moment I'm I would say satisfied. So before to go ahead to reassembly, I just want you to see how beautiful is this HP logo printed on the scale of the CRT. It's fantastic. So this is something that we will not see anymore. Just on that age they were producing, and they put attention on details like that. So time to start to the assembly and put back all the knobs and see the result. I also have to clean the glass that stay in front of this CRT. So let's go ahead. Alright, I'm back to the power supply board. I have just received the replacement for bridge rectifiers, and this is what I found. This is the model KBL608. The lettering unfortunately is a bit damaged, which is better than the original in terms of capability, but unfortunately the case is a bit wider, and also the legs are spaced a little bit wider, so I had to modify a bit the shape of the legs in order to fit in the PCB. Luckily the holes are capable to receive this kind. This bridge is rated at 6 amp 800 volts, so should be more than enough. And this is the right replacement for the original. The model is W04M, which is the same that I have removed in the wrong place, that was faulty. So let's go ahead with the soldering and make all the joints and clean and see if there is anything else obvious. In fact, something that I don't like is this kind of capacitor mounted like that should be insulated, since those two pads are not connected with this copper area, so it's quite dangerous that some short circuit can happen here. So at least I will insulate the terminals, and while I will try to find a nice replacement, since I don't like this way to mount capacitors. So let's go ahead with the reassembly. Okay, everything is reassembled, and I have already performed an initial test, and unfortunately is behaving the same. So after the replacement of the bridge rectifiers, well, does not improve anything. So if I switch on, now I am channel B, but it behaves identically to channel A. I'm still having 5 volt ripple, and as you can see, it's having difficult to lock the trigger. And what I have discovered, that if I add one capacitor to the line, look at that, it seems that it's missing the capacitance of some capacitor, and I suspect that C6 is a 10 microfarad right on the 43 volts, is this one, only 43 volts output. I have just jumped on it, and from 5 volts is dropping down to 500 millivolts, the ripple. So I believe that these capacitors, despite I have tested, it seems that under voltage it's behaving like an open capacitor. So I want to replace it and see if it makes some change. Well, I have removed 6.6 and tested again, and look at that, 5000 picofarad. So it's about a bit less of 6 nanofarad. Of course, it's an open capacitor and must be replaced. So hopefully this will improve a bit the behavior of this oscilloscope. The capacitor replacement has improved a lot the instrument stability, and indeed I am not having any more weird behaving while I'm changing the time base. Well, there is some contact problem, and perhaps also some range that is not functioning very nice. However, yeah, seems that has improved a lot. So now I will attach my time mark generator and see the horizontal amplifications, if it's working fine or not. Before to do that, just for curiosity, I have grabbed the oscilloscope probe and attached it to the TDS, and it's reading very low ripple now. We are at yeah, just a bit more of 10 millivolts. So it's like should be, So it seems that the problem is fixed. So let me grab the time mark generator and do the setup. Here we are. This is the time mark generator, and it's clear that it's out of alignment, the oscilloscope. Since if I increase the scale illumination, well, I'm running at 0.2 millisecond, and as well as is the time mark setting, and it's clear that if I set exactly in the center, it's gain too much, so the instrument need a nice calibration, and moreover the trace is a bit out of alignment, so it's not straight as it should. And however, if I look at the markers here, they are pretty fine, so it's not clear to me why this line is so thick, and actually I don't like it. I have checked all the ripples and they are perfect, so the only thing that remain is some noise that is running in the instrument for some reason, or if there is some misadjustments in the high voltage section, or it's simple design that behave like that. So it's time to do the complete alignment and see how it will be. Just a quick check on the time mark generator. Look at that, 200.00 microseconds, so it means 2 milliseconds. And yes, here we have 4 divisions each side from the center. So if we go down, and set to the same setting, look at that. One is almost not visible, and the other one is at 4.5 centimeters. So yes, for sure need the calibration. Okay, this is the finished instrument. The adjustment procedures were quite long. I found almost all the controls out of alignment. It seems that the person that have attempted before me to repair it has touched everything. However, that is the past. Now the instrument is fully functional and responding on all controls as it should, including the delay. It is very, very precise. It's very precise instrument. So despite this analog instrument, it's very precise, and HP has always has produced fantastic instruments. So this is the time that I can say I can add to the lab this oscilloscope, mostly because of high sensibility in the input, and I think that I wrongly said we are at microvolts. Actually we are at millivolt, and it is 5 millivolt of sensibility, so it's of course very sensible, but not microvolt. We are going to, let me switch off the inputs, we are going to 5 millivolts. So well, it's a very sensible instrument,
more modern, I think that we can only go down to 20 or maximum 10 millivolts per division. So this is more sensible, and actually I will need this kind of sensibility to adjust another instrument is a frequency counter that the input section must be adjusted with such sensibility. So that's it for this video. I hope you enjoyed this repair, and I will appreciate a thumbs up. Don't forget to subscribe. More repairing videos are coming in. So thanks for watching. Goodbye.